All right, so now that we've covered a little bit of linear functions, what we're going to do is we're going to put them in a simultaneous sort of scenario. Okay, so what do we mean by simultaneous functions? Simultaneous functions are essentially, if you have two functions, they should both satisfy a set of constraints, right? So for example, you have the two functions, y is equal to 2x plus 5 and y is equal to 3x. Okay, so these are two equations, and to solve them simultaneously, what we mean is we want to find x and y such that both of these equations are satisfied. Okay, so in this case, or I can maybe think of a simpler case, right? So what if, for example, if I have y is equal to 3x take 1 and x plus y is equal to 3, all right, in this case, what I can do is I can have the solutions y equals 1 and x equals 1 and y equals 2, and you can see that if I plug them in, right, I'll plug them in right here. So y equals 2 is equal to 3 times 1 take 1, which is true. Okay, in the second one I have 1 plus 2 is equal to 3, which is also true. So you can see that the value 1 comma 2 satisfied both of the equations. So when we're talking about simultaneous equations, that's what we're looking for. We're looking for a bunch of values that satisfy the given equations. Okay, so there's a few ways to go about solving these things. We can either try every possible number, all right, just try every combination until it works. That will work eventually, and if it's something like 1 comma 3, maybe you can arrive on it quickly, but it's very inefficient. So let's talk about some actual methods to solve it. So the first main method you can use is called graphing. All right, and as the name suggests, you just graph the functions. All right, so if I had, for example, this same equation here, right, so what I'm going to do is I'm going to get these functions here and write them out just so they're closer to us. Okay, 3x take 1 and x plus y is equal to 3. What I'm going to do further is just rewrite this in the slope-intercept form, just because it makes it a bit easier to graph. Okay, so now we have our two functions. We're going to go ahead and graph them. So for the first one, all right, the way you graph them is you just find 2 points and then connect them. So for the first one, the first point can be when x is 0, what is y? Well, y is 1, all right? So if I put x equals 0, y is equal to negative 1. Okay, you can see that in the value of c as well. All right, next, what about another point such as x equals 1? At that point, what is y? Okay, at x equals 1, if I put that in here, 3 times 1 take 1, y is equal to 2. Okay, so put that here. Okay, and these are now our 2 points, and all we do is connect them. Okay, obviously in an exam you would want to use a ruler, make a proper line, but in this case this suffices. All right, then for the next one, okay, similar sort of concept. Where does it intersect the y-axis? At 3. You don't have to, your points don't have to be the ones that I'm saying, they just have to be points that are on the line, and as long as you connect them, you'll be all good. Okay, and another point can be, for example, y equals 0. At that point, x is equal to 3. Okay, so this is your second line. Okay, now the question is, where do they intersect? Well, they intersect right here at 1 comma 2, all right, which is the point we found here as well. Okay, so that, as you can see, is one way to solve simultaneously linear equations. You graph them and you find the intersection point. Okay, the next thing is called substitution. Now this is personally my preferred way of going about simultaneously linear equations, and yeah, I need to learn how to say that, but this is my preferred way to go about them. And what you do is, really, you have these two equations, right? And what you do is you want to write either x in terms of y. Okay, so you want to get like the first equation. Let's say this is equation 1 and this is equation 2. You want to get the first one and then write it in terms, write So make either x or y the subject of it. Okay, so in this case, y is already a subject. By subject, I mean it's by itself, all right, on one side. So in this case, y is already a subject because it's by itself on the left-hand side. And in this case, for the second one, for example, if I wanted to make y the subject, what I would do is I would move the x to the other side. Okay, but that's not what we are focusing on right now. We just do it for the first one. Okay, next, what we do is we substitute that. So we take y is equal to 3x take 1 and put that in place of this y over here. Okay, because what we are saying is that y is equal to 3x take 1, right? Therefore, x plus y is the same as having x plus 3x take 1, right? And then that is equal to 3. So now we can go ahead and solve this like a normal algebraic equation, solving for x. Okay, it's very simple stuff that we've been doing for a long time. Okay, we go ahead and do that. This gives me 4x take 1 is equal to 3. 4x is equal to 3 plus 1. Okay, 4x is equal to 4. X is equal to 1. Okay, oh good, but no, we're not done yet. Okay, we found the value for x. Now we just need to put that back into our first equation, which gives us y is equal to 3 times 1 plus 1 take 1, which is equal to 2. Boom. Okay, again, we get the same solution as before. Okay, the last method I'm going to talk about is called elimination. Now, this is one of the most efficient methods out there. It's very quick, but it is a bit hard to wrap your head around. So please focus a bit, and trust me, once you get it, it's very comfortable to work with. So what you first want to do is you want to take your equations, right? You want to take your equations and you want to rewrite them so that everything is sort of aligned, right? So your x's and y's are in the same spots. So a quick way to do that, would be to, for example, I can just go ahead and bring the x to this side. So I have y negative 3x plus y, whoopsies, is equal to negative 1, okay? And I have x plus y is equal to 3, okay? And now what I want to do is, now that you can see how they're aligned, right? Now what I want to do is I want to subtract both of these equations, okay? So I want to subtract this one from the first one. And when I do that, what I get is negative 3x take x, right? Which results in a, so if it's like a normal subtraction that you would do in a, like with numbers, all right? It's the same thing we're doing here. So you have negative 3x take x, which is negative 4x. Okay, you have y take y, which is 0. And you have negative 1 take 3, which is negative 4. Again, that gives x is equal to 1. And now you follow the same process where you sub it back in and you get 2. Okay, so that's essentially the process for elimination. But for elimination, there's this like little trick that you have to know, is that in a scenario like this, right? If you have an equation like this, right? Now, if you normally just try to go ahead with the elimination, you have a problem that the variable, one of the variables won't cancel out. You still have 2 variables left. So I can go ahead and show that to you. So I can do negative. All right, I can try and subtract it. I'll get negative y. 3x take 5x is negative 2x, right? And I don't even need to bother with the last term. But the point is that you'll still have 2 variables in your equation and you really haven't gotten anywhere. So what you really want to do before you go ahead and do this is you want to choose a variable, whether it's x and y, whichever one you want, and make the coefficient of that variable the same in both equations, okay? So in this case, I want to do want my y to have it. So I'm just going to times the first equation by 2, which would give me 2y, 6x, and 2. You have to multiply both sides by 2. And now you can see that the y has the same coefficient. So now when I go ahead and subtract it, I would get 2y take 2y, giving me a 0. 6x take 5x, which would give me a 1x, and then 2 take 9, which is -7. All right, and we can go ahead from there. But that's all there is to it, okay? These are the 3 methods you need to know, and these are how you go about it. That's all there is to simultaneous linear equations, and hopefully you can go ahead and practice them a bit, get very familiar with it, and enjoy it. Hey guys, 2 things. If you do have any questions regarding the content we just covered, just go ahead and drop that in the comments. I'll make sure to get to that as soon as possible. And secondly, if you liked the video or if you got anything that was useful from it, make sure to check out the website, Prep Folders. There's so many more videos like this, so many more resources, practice questions and all the lot. So just go ahead and have a look. If you need help, there's some tutors and mentors there as well. So just have some fun over there. And yeah, we'll see you on the other side.